Hello, my name is Kanyetta Nelson. Today I will discuss logistic regression and complete a problem using this method. In my attempt to explain logistic regression, I will concentrate on three questions. The first question is, what is logistic regression and what are its conditions? In the second question, I will discuss the difference between logistic regression and discriminant analysis. And for the third and final question, I will perform a problem that addresses logistic regression. In this problem, I will determine if there is a combination of independent variables, which include gender, parents, education, mosaic, and visualization test that predicts the dependent variable, which is whether or not students will take Algebra 2. What is logistic regression? According to Agressi, logistic regression is a category of generalized linear statistical models that permits a person to predict a discrete conclusion from a set of variables that can be continuous, discrete, dichotomous, or a mixture of these, where the dependent variable is generally dichotomous. In our textbook, our authors give us three conditions that must be met in order to be able to perform logistic regression. These conditions include the dependent or outcome variable must be dichotomous and mutually exclusive. This means that the dependent variable can be labeled 0 or 1 and can only be included in one group. Examples include male or female, pass or fail, and other examples where only two choices are available. Another condition that must be met is that a large sample size is used. There should be a minimum of 20 cases per predictor with a minimum of 60 total. And the third and final condition is multicollinearity is a potential source of confusing or misleading results and should be assessed as well. There are several differences between logistic regression and discriminant analysis. However, the one that stood out the most is that independent variables in logistic regression can be categorical, continuous, or a mixture of continuous and categorical, whereas independent variables and discriminant analysis can only be continuous. According to our text, this is why logistic regression is used more than discriminant analysis in health-related fields. Another distinguishing factor between logistic regression and discriminant analysis is the fact that logistic regression has a fewer number of assumptions than discriminant analysis. There are only two assumptions associated with logistic regression according to our text. These assumptions are observations must be independent and the independent variable must be linearly related to the logit of the dependent variable. The following assumptions were given for discriminant analysis according to our text. Relationships between all pairs of predictors must be linear. Another assumption for discriminant analysis is multivariate normality must exist within groups, and the final assumption is population covariance matrices for predictive variables must be equal. Now that we know what logistic regression is, we will now predict a dichotomous outcome from continuous and dichotomous predictors. using the HS data new data file, we can use logistic regression to answer the following problem. Is there a combination of gender, parents' education, mosaic, and visualization test that predicts whether students will take Algebra 2? The first thing that we checked for was multicollinearity and found that it was above 0.87, which demonstrated that there is little multicollinearity in this problem. Then we ran the logistic regression with Algebra 2 as the dependent variable and gender, mosaic, visualization test, and parents' education as the independent variables. Enter was used as the selected method to enter all the variables in the covariance box at the same time. The options box was selected to ensure that a confidence interval of 95 was checked to provide confidence intervals for the odds ratio of each predictor's contribution to the equation. Then the Continue and OK buttons were clicked to give logistic regression output for the data where various charts were provided. As can be seen in the first chart, these results can be attributed to all 75 participants' responses. No participant left out any data. That means that it was 100% participation rate. All right. The second chart shows that if a student took Algebra 2, then that information was coded 1, and if a student did not take Algebra 2, then it was coded 0. Another chart that was provided with the output data was the classification table. In the classification table, it was demonstrated that 53% of students did not take Algebra 2. Therefore, if a person were to say that no students took Algebra 2, he or she would be correct 53.3% of the time, as indicated by the 53.3 highlighted under the percentage correct. The variable and the equation graph shows that the odds of successfully predicting that a student would not take Algebra 2 is not significant, as indicated by 0.64, which is greater than a significant value of 0.05. However, the variables not in the equation graph indicated that individually, gender, visualization test, and parents' education significantly predicted whether a student would take Algebra 2 or not, but Mosaic did not. The omnibus test of model coefficients table indicates that when we consider all four predictors together, the model is significant. The highlighted sections and Table 2 indicate that about 28% or 37% of the variance and whether or not students took Algebra 2 can be predicted from the linear combination of gender, mosaic, visualization test, and parents' education. Table 2 indicates that mosaic fails to predict Algebra 2 whether used alone or with the other predictors. Gender significantly predicted Algebra 2 when it was used alone. However, when all four variables are considered together, gender no longer significantly predicts Algebra 2. Parents' education and visualization are significant predictors when all four variables are considered together as well as alone. This is a summary of my results along with a table. Whether a student took Algebra 2 was significantly predicted when gender, parents' education, mosaic test, and visualization test were considered together. And Table 1 presents the odds ratio, which suggests that taking Algebra 2 increases as parents' education and student visualization scores increase. Below are the references that were used to complete this presentation. I hope that the information provided was helpful, and this concludes my presentation. Thank you.